Willie, can you read this question? Atom is very small.
Atom is very small and it is impossible to weigh the mass of an atom using any electronic balance. Thus, chemists use the concept of relative atomic mass to estimate the mass of an atom. Directly show the comparison of mass of atom J with 1/12 of carbon 12 atom.
Okay, thank you, Willie. So atoms, they are too small. Okay, too small. So we cannot using any electronic balance to measure it, right? That is the reason. So we will use what? Relative atomic mass. Relative atomic mass. So if we say relative, meaning that it compare with something. Okay. So in chemistry, we'll compare it with what? We compare it with carbon 12. Okay, carbon 12. So it's like this, So you can have a look here. This one is take out one, meaning that this one is as a 1 unit, 1 unit. Okay, so 1 unit of carbon 12, 1 unit. So it divides into 12 units, like this. So meaning is J. Okay, J stand for how many 1/12 of the carbon 12 atoms. So we just calculate 1, 2, 3, 4, 5, 6, 7. So it is compared to the carbon 12, it has 7 parts or 7 units. Okay. So now the first question. Okay, why does the carbon 12 as is chosen as a standard? Okay. Kenapa kita pilih carbon 12? Yeah, so if this question asked, what should you answer the questions? Okay, there are several reasons actually. So you just remember 1 or 2 enough already. Okay, so carbon 12. So carbon is a solid at room temperature. Okay, it is a solid, meaning that it can be handled easily. So this one is a main reason. Okay, because previously, okay, you can have a take note on that. Previously, they used the hydrogen to compare. Okay, firstly, secondly, they use the oxygen to compare, to take the relative atomic mass. Okay, then finally, it only comes to carbon 12. Okay, then we stick to carbon 12. Okay, so first and second, why they change it at the end, because they are gas. Okay, they are gas. So it's a little bit difficult, okay, for them to compare using the gas. Okay, but solid, but carbon 12 is a solid, so it's easily to be handled. Okay, so beside that, so this you can write these two. Okay, beside that, just for your information, carbon 12, it combines easily with other elements, or it is found in most substances because all the organic substances okay, around us, it has a carbon compounds actually. Carbon. Then carbon 12 is a major isotopes with the abundance of 99%, or relative atomic mass of the carbon 12 is exactly 12. Okay. So now B, based on the diagram, state the relative atomic mass of the J. So meaning that if you compare like this one is exactly 1, 2, 3, 4, 5, 6, 7. So if it has 7, meaning that this one J, the relative atomic mass is 7. Okay, it's 7. Okay, 7. Okay, C. Okay, C. Okay, Faris, can you read the question?
In an experiment, J is burned in excess oxygen gas to produce J oxide, J2O.
Mm.
Write the chemical equation for the reaction.
Okay, thank you, Faris. Okay, so J here is 7. If you look into the periodic table, 7 actually is what? 2, 7 is okay, 7. Okay, so this one actually is a lithium, lithium J. So when it combined with oxygen, excess oxygen gas, so formula for oxygen gas you can write down like it's O2. So lithium is the metal. So it's the metal. So it is the atom. Oh, it's the atom. So J. This one J, no charge now. Then it will produce a J2O. Okay, J2O. So meaning that how are you going to balance the equation? Can you try to write the chemical equation? J burn in excess oxygen, meaning that J plus the O2. Okay, to produce, then produce J oxide, J2O, all given to you already. Okay, huh? So if you have this, can you balance the equation? Okay, so you try, write down the answer. Later you check your answer is correct or not. Huh? Okay, done already, class? Sudah siap? Okay, Dawi, good to join, Dawi. I try to pay attention now. If you feel you will fall asleep, you can turn on your camera. Okay, check. 4J plus O2 produce 2J2O. Okay, semua betul kan? Okay, so you can use the J or you can replace with the real one is a lithium. Okay, don't use sodium. It's a lithium. Okay, why 4J? Okay, to balance the equation. Kamu tengok sini ya. Okay, we look into the O first. So O2 here, right? 2O here. Got O2, but here only one O, correct? Oh, understand? So how to balance? So we times 2 lah. Darab 2 sini. O jadi 2. But J2 here times 2, so it will be 4J. So meaning that here you need to times 4. Okay or not? Answer? Boleh ya? Sila tanya betul. Kalau tidak faham, sila tanya. You have to ask. Okay, good. This is a good learning attitude. Okay. Next question. Okay, Matthias, can you read the question? By using
the relative atomic mass of atom J from your answer in 3B, calculate the mass of J needed to react completely with 0.2 mole oxygen gas.
Okay, thank you, Matthias. Okay, so now, class, now we look into this question. Okay, so first, Last week we discussed already. First, what we need to find out? We need to find what? Find the number of mole. Correct? Okay. First, you have to find the mole. Second one, we have to find the mole ratio. Number 3, you have to find what? Find the one asked in the question. Here will be mass of J. Is that okay? So first here, okay, we find the mole. Okay, now given already, given already in the question, mole for the oxygen is 0.2. Okay, so class, where is oxygen? Oxygen is this one, right? Okay, so this one is oxygen. So how many mole? 0.2 mole. Okay, so for oxygen. So first, this one given to you, mole is for oxygen is 0.2 mole. Correct? Okay, step 1, any question? All can follow or not? Adrian, okay or not? Can I? Tawi, 可以吗? Can or not? This one, more for oxygen, 0.2. Is that okay, Tawi? 可以吗？给老师反映一下。Okay, next. No one got problem, huh? Okay, next. Okay, number 2, mole ratio. Class, what is the mole ratio you need to compare? Oxygen, definitely you need to compare. You need to compare with what, class? BB, for the step number 2, mole ratio, you need to compare what ratio?
J.
Okay, good. O with the J, correct? Huh? You compare O with the J. So mole ratio, O with the J is, this one is directly like this. Okay, so we can do the second one. Okay, mole ratio. So here, okay, 4 mole J, right? Produce how many mole of oxygen? 1 mole, correct? Oh, okay. Or you can write like this. Like this also can. If you want to write like this also can. You just compare O2 with the J. You write J first also can. It's up to you. Kalau ikutkan equation dia, okay, you can write J first, then O2 also can. So more, okay, more for this one is 4, correct or not, from equation? So it's 4. This one is what? Oxygen. It's 1, right? Correct, 4. This one 4, this one 1. Nothing means 1 lah. Okay, yang ini okay ke? Boleh? Anessa, okay or not? Jonathan, okay or not? This one 4, this one 1. Can or not? Can, okay, Jonathan, okay mah? Can Jonathan can respond
大概
big 可以吗？
大概可以啊。
4跟1知道哪里来哈？ You know where the 4 and 1 come from? Come from the equation. Okay. Now here 0.2. 0.2 is for what? For the oxygen. Don't put the wrong side. So if here is 0.2. So what about this J? Okay. How to get? Gabriel. How to get the J? If 4, 1. Okay. Then all is 0.2. How about J here? What is the value?
4 times 0.2 more.
Yes, correct. So what is the value? You get?
0.8.
Yes, correct. It's 4 times, right? This one 1, this one 4. Meaning that if here 0.2, meaning that times 4, 0.8 more. Okay, and ini okay kah? Meaning that now your mole for the J is 0.8. Okay, huh? 0.8. Then finally you can find the mass of the lithium. So it's 0.8. Yeah, 0.8 from here. Then relative atomic mass for the J, right? Just now where is 7. So meaning that 7 is come from here. Oh, come from here. So you get is 5.6 gram. No? Okay. You need at the end, you must write. Okay, any question? Okay, follow. Now, next question. Question number 2. Okay, for tonight. Okay, now I will ask one student to read. Okay, Trinity, can you read this question? Diagram 2.
Diagram 2 shows reaction between X oxide and hydrogen gas.
Okay, so okay, hydrogen gas, X oxide, no? So hydrogen gas, what is the formula, class? Hydrogen gas is this one, right? This one. So formula is H2, is that okay? And X oxide, X oxide is XO given to you here, XO. So react with this one. Then we produce what? X with what? This one H2O. Okay, so this is the equation. Now, what is the meaning of chemical formula? Chemical formula. This one is a standard answer. It shows the actual number of atoms. Actual number of atoms for each elements in a compound. Okay, in a compound. Okay, actual number of atoms for each elements in a compound. Okay, Adrian, you just came in, so now we are talking about this question number 2, for this set. Okay, question number 2 here. Okay, so definition for chemical formula. So you write down, Okay. Now B. Okay, Jerome, can you read the question and give your answer?
State the chemical formula of hydrogen gas.
What is the answer? So it shows the number of atoms, right? For each element in a compound. So like this. What is the formula, Jerome?
H2.
Yes, H2. Yes, very good. H2, very simple, right? Okay, it's a formula H2. Okay, this one will be subscript. Okay, normally we will write like this. H2. Okay. Okay, thank you, Jerome. C. Cynthia, can you read the question?
Deduce two information based on diagram 2.
Okay, deduce two information. Okay, from this diagram. Okay, what can you write out the information about this?
There's 2 hydrogen.
Okay, so try, Cynthia.
Right equation is it?
This one is a equation, yes. So what information you can get from here?
Oxygen.
Okay, just continue, Cynthia. Where you can see the oxygen.
I don't know, teacher.
Okay. Never mind. Okay, who else can try? What information you can see? You will write like this, right? Okay. So normally, what can you write, class? Okay. Remember, there are a few things you can write. Okay. So you can write what? You can write X oxide react with hydrogen to produce X atom and water molecule. This one is the first one. You can write. The second one, you can put in the mole like this. Nothing means one. So meaning that you can write 1 mole of XO react with 1 mole of hydrogen gas, produce 1 mole of X and 1 mole of water. So this one you can write. Okay, you can write down. These are the information you can write. Okay, now this one try. So for D, I would like to ask Adrian, can you read the question? Relative.
Relative formula mass of X oxide is 80. Calculate the relative atomic mass of X.
Okay. Now given to you, so you have to be careful here. X oxide. So class, X oxide given to you. What is the formula for X oxide? So X oxide, you can see the diagrams here. So what is the formula? 1x, 1 O. Correct or not? So meaning that your outside of x is the XO. XO. So can you find the x? If XO is 80, so what is the x? So this one we can try to calculate now. So this one is XO, right? So XO equals to 80. So you need to find the x, right? So O, what is the AR for O class? Who can remember? Siapa ingat? Apakah AR untuk O? Hmm?
16啊，老师。
Yes, 16, 16. O is 16. Okay? O is 16. Okay, now so x you want to find plus O is 16 equals to 80. So what is x? 80 minus 16. So you get 64. Yeah. For the relative academic maths, if relative no unit, no need to put in gram. No. Okay, Anand? Any question you want to ask? Can follow. Any question? Don't be shy. Please ask. Okay, now I like you to try Malacca question. This one is the empirical formula. Okay, empirical formula. This one more to calculation. Okay, so this one is as experiments diagrams. Okay. So for this experiment, if you have notes, you can take it out now. Okay. I'll let you try to answer the question. Okay, I give you around 3 to 5 minutes. You try to find the answer for this experiment. Chapter 3, Chapter 3. Okay, class. Okay, now we check this question. Okay, discuss this question now. Okay. Cynthia, can you read the question, please?
Diagram 2 shows the apparatus set up to determine the empirical formula of magnesium oxide.
Hmm.
A. When carrying out this experiment, why does the crucible lid need to be opened once a while?
Okay, so meaning that this lead, okay. So class, if you see this question, this experiment, this question or this question will be asked, okay, in the exam. So first one, why this lead need to be opened once a while? Okay, you hit it, right? Okay, you need to open a while, then close it back. Okay, and from time to time you have to open again. Okay, what is the purpose? Yeah, Cynthia, do you?
To allow oxygen to enter and react with the magnesium.
Correct. To allow the oxygen to enter the crucible so that the magnesium can react with the oxygen. Is that okay? Yes, very good. To allow the oxygen better to enter. Oh, we don't write A lah. Kalau udara itu banyak benda, so we let the oxygen. Okay, now the result, okay, results. Okay, so this one, I would like all of you to know how to calculate this one. Okay, so first one, crucible with the lid, kosong mangkok pijar dengan penutup. So meaning that this one first, nothing inside yet. So is 26.35 gram. Okay, now crucible with the lid, and then you put in the magnesium ribbons, so it becomes 28.75. Okay, let's say now is this one, we put A lah, A. This value is A. This one is B. Okay. So class, from these two, can I find the mass of the magnesium? Can or not? Boleh kah? Anessa. Can I find the mass for the magnesium or not? From A and B. Yeah, Anessa? Anessa masih ada kah? Jerome?
What is the question just now, teacher?
Yeah, what is the mass of the magnesium? Ya, apakah jisim bagi magnesium di sini? Kita tolak saja kan? Okay, which one minus which one?
B minus A.
Yes, B minus A. Now you can get the magnesium. Okay, now we look into this one. Let's say it's C. So this one is after you heat it, right? After you heat, and then the magnesium react with the oxygen. Okay, so it forms a magnesium oxide. Okay, it's a C. So what we can find from here? Magnesium oxide, right? This one is magnesium. So what mass we can find from here? Siapa tahu? Okay, what minus what? Okay. We compare B and C. This one is a magnesium. This one is a magnesium oxide. So what is the extra things here? It's oxide, right? Okay, oxide. Oxide means that it's oxygen here actually. Lagu apa tu, Jerome? Jangan ada yang buka account sini lepas tu main game saja. Okay, so okay. So C minus B, actually we can get the oxygen oxygen. Okay, so meaning that class for this experiment, we need to find the magnesium. We have to find the mass for the magnesium. Okay. Is the B minus A, then another one is the oxygen. Is the C minus B. Okay, gram lah. Okay, so from here you can calculate. So mass for the magnesium, what is the value class? Trinity, have you calculated for magnesium? What is the value? Then oxygen, what is the value? For oxygen, Anessa, can you calculate the oxygen? What is the mass?
Teacher, is it 2.4?
2.4 gram, 2.4 gram, meaning that 28.75 minus 26.35. So you get 2.4 gram. Correct? How about oxygen, Anessa? Berapa nilai? Oh, Anessa.
Teacher, I don't have paper. I haven't print yet.
You kena. Tapi tengok dari sini loh. Tengok dari sini. 30.5 C. Kamu ada printer dekat rumah kah? Tolak 28.75. So you get
1.6.
yes, 1.6 gram, 1.6 gram. Okay. Now, can you calculate the number of mole? Anyone? For magnesium, you have the mass. Okay. So you have the mass. How to get the mole if you have the mass? Bisa ingat kah? Apa formula ni? More is a sorry. More is not here. This one is mass. This one is a mole. This one is molar mass. Correct? So, can you calculate the number of mole for magnesium and oxygen? Okay. Okay, Matthias, can you calculate the mole for the magnesium? Adrian, is you count for the oxygen. What is the number of mole? Okay, sudah?
0.1 mole.
Okay, so magnesium is 0.1 mole. Okay, another one. For oxygen, magnesium is 0.1, correct. Oxygen,
0.06.
0.06. Adrian, what is how you get 0.06? What is the mass?
1.6.
1.6. Okay. Molar mass for oxygen?
16.
16, right? Okay. Not 32 for oxygen. Don't divide by O2. It's O only, so 16. So what is your answer? 0.1 also. Okay. For magnesium, is 2.4 over 24. So you get 0.1 also. So both are 0.1. Okay. 0.1. So also 0.1. Okay, both are 0.1. Okay, thank you, Matthias. Now, if more are 0.1, 0.1, so what is the empirical formula? Ratio 0.1, 0.1. So you simplify, divide by 0.1. Okay, no? So you get 1, 1. So that's why you get ratio is 1, 1. So meaning that Mg1 or 1. So you'll be MgO. Is that okay? Semua boleh ikut kah? You know? Okay, Faris. So class, if this empirical formula for the magnesium oxide, so normally this question will be answered. So you must know how to answer the questions like this. Okay, now I think okay, this one is the SPM, SPM 2021. Okay, another one, empirical formula for oxide of R. Okay, so class, you see, this apparatus and this apparatus, they are different, right? So remember this. Okay, record down this one. This is for reactive metal. This apparatus for reactive metal. Okay, like magnesium or zinc. But normally, if you see this one, they will use magnesium. Okay, then second one, this apparatus, this one is for the unreactive metal. Okay, example, copper. Okay, copper. Lead. So far, I only see these two examples. Okay. So this one is using the hydrogen. Hydrogen flow it into the hot R, oxide of R. Okay. And this one is asbestos pepper. This one is a flame. Okay, so you have to hit it strongly. So here, what happens? What happens? So hydrogen, what is the formula, class? Hydrogen gas. Hydrogen gas is H2. So remember. So how to get the H2? Normally we use the acid. Let's say hydrochloric acid. react with any metal, like say magnesium metal. So these two react, you will produce a hydrogen gas from here. Okay. Okay, A. I'd like to ask one student to read. Okay, Gabriel, can you read the question?
Which question, teacher?
A.
Hydrogen gas can be produced through the reaction of magnesium and an acid. That one acid that can be used.
Okay. So what is the answer? What acid? Any acid you know?
Hydrochloric acid.
Yeah, given to you already, right? Hydrochloric acid. Or any acid now, any acid. Okay. Nitric acid also can, sulfuric acid also can, huh? Also can. Here, step, you can use the name, you can use the formula, doesn't matter, huh? Okay, now B. Suggest the oxide of R. Okay, just now I give you the answer already, right? So you can choose copper or this one, copper or lead. No? Okay, copper or lead. But actually, you can choose silver, tin, iron also can. No? But normally, we will choose the copper. Okay, copper. So next, okay, here. Okay, this one slightly different a bit. Okay. So here, combustion meaning the empty apparatus. And kosong. Okay, nothing inside. Now here, mass of the combustion tube, asbestos, pepper, and oxide R. So meaning that now you have oxide R. Okay, put in the oxide R already, huh? Okay. Now, number 3, mass of the combustion tube, asbestos, pepper, and R. This one is R plus. Okay, now again, let's say this one is X, this one is Y, this one is, I use PQR easier. Okay, P, Q, R. Okay. Now, normally like this, this apparatus, we need to find out the one mass of the R and then mass of the O. Okay, because oxide of R. So class, how to find the R, mass of the R? What minus with what? PQR? Anyone know? Okay, shooting. What do you think? How to get the mass of the R?
Q minus R.
Q minus R. Q minus R. Q minus R can get the R, huh? Class, what do you think? If Q minus R, you get the O, correct? Oh, Shixing. If Q minus R, you get the R, correct? You'll get the O. Because both got R. Is it? True?
R minus P.
Yes, R minus P. Very good. Okay. R minus P. Because P is empty, R got R here. So R minus P is. So the mass is R minus P. Okay. All this time you mentioned already, huh? So Q minus the R. You get all. Okay. So now can you calculate it? Calculate the empirical formula. Okay, so now we mentioned already, huh? So value. Okay, so R is R minus P. Okay, means 36.34 minus 32.50. Okay. And for oxygen is Q minus R. So it means that 37.3 minus 36.34. So it's 36. Sorry, 0.96. Okay, the mass. Anything you want to ask? Jonathan, okay, this mass. Trinity, okay?
我 OK， 我 OK。
Okay, okay, good. Trinity, okay 吗？
OK，老师。
Okay, next, number of mole. Again, mass over molar mass. Molar mass, how to get? Here got value. Given to you here. So you just use the mass over the molar mass. So you get 0.06. Both are 0.06. Okay. The ratio, if here both are the same, so divide by the same value. But now, let's say more, you get two different values, right? Okay. We'll choose to divide by the smaller more. Choose to divide by smaller more. Okay, right? Let's say 0.01, this one 0.02, for example. So if divide by 0.01, choose the smaller one. Okay. So ratio now is 1:1. So what is the empirical formula, class? What is the empirical formula?
RO.
Okay, R101 are all. Okay. Empirical formula is RO. Okay, RO. So 4 marks. This here got 3. Then here got 1. So 4 marks.